So in this lecture, first we'll be considering how to find out cross product between two vectors in their Cartesian component form. Now, if you want to find out the cross product between two vectors, suppose A bar and B bar in their Cartesian component form, in the first step, you just write down this cross product expression in the Cartesian component form of the two vectors. That means if the two vectors are A bar and B bar, then first you write A bar cross B bar is equal to AX I cap plus AY j cap plus AZ k cap cross BX I cap plus BY j cap plus BZ k cap. Now you form a determinant whose first row is I cap j cap k cap, whose second row is the components or scalar components of the first vector, that means x, ay, az, and whose third row is the scalar components of the second vector, that means bx, by, bz. And if you evaluate this determinant, then the result comes out to be the same as the cross product between the two vectors a bar and b bar in their Cartesian component form. So what is the rule for finding out the cross product between two vectors in their Cartesian component form? So the rule is stated here. To calculate the cross product, form the determinant whose first row is I cap, j cap, k cap, second row is components of the first vector, that means scalar components of the first vector, and third row is the scalar components of the second vector. So this is the rule using which we can find out the cross product between two vectors in Cartesian component form. Next comes gradient of a scalar field. The gradient of a scalar field, suppose the scalar is t here, is given by, you see on the left hand side, this symbol is actually del bar along with t. As a whole, it is called grade of t or grade of the scalar t. So here this del bar along with this t is actually called grade of the scalar t or simply grade of t. And this is given by I cap del t del x plus j cap del t del y plus k cap del t del z, where the operator del bar, that means this operator alone, which is also called del operator, is given by del operator is equivalent to I cap del del x plus j cap del del y plus k cap del del z. That means this del bar is an operator which is actually I cap del del x plus j cap del del y plus k cap del del z. And del bar is also called a vector space differential operator. Now, you have to note here that we can always find the gradient of a scalar, but gradient of a vector is meaningless. That means here t is a scalar, and always gradient of a scalar is possible, but gradient of a vector quantity is meaningless. Also, gradient of a scalar is a vector quantity. You just see here, this gradient of scalar t is accompanied with this I cap, j cap, and k cap. This means that this gradient of the scalar t is a vector quantity. So gradient of a scalar is a vector quantity. Thank you.